So, okay, cool. Looks like it's recording. The first thing I wanted to go over was just to see how familiar, how much you remember. So I might go over some things that are familiar. I specifically wanted to go over how to get these programs on your computer. So if you just kind of follow me. And does everyone feel comfortable with like what we did at the end of the thing? Give me a thumbs up if you remember the program well and you felt really comfortable with your robot, like it was working when you left. Yeah. Liliana, what about you? Was it working for you when you left?
Yes.
Okay, cool. Perfect. I just wanted to make sure. And so if we're gonna assume that you're able to get a working robot and everything was good to go there. The thing to remember is, do you have that blue cord that was in your kit? That's what you're gonna use to connect to your robot and connect that to your computer. And you don't have to do that right now. I'm just making sure that you're aware. Use that blue cord to connect your Arduino to your computer. The next thing that you're going to do, there's two different programs that you can install. There's the Arduino program, and you can see my screen, right? Everybody can see my screen? Cool, perfect. So this is the Arduino program. This is what we call a integrated development environment. This is where you can write code. So obviously Arduino code goes to your Arduino board. I'm going to show the Arduino part later, only because I want to show you mBlocks first. This is what mBlock is. So I'm just going to say this so that it's out there, but it's not super important. mBlock is also an integrated development environment, just like Arduino, like the one I just showed you. However, this one uses blocks like this that allows you to code. And what it does is it converts that code into Arduino code and sends that to the Arduino. So it's basically adding a step in between that allows you to visualize what you're doing. Okay, so how you get mBlock onto your device. So I'm gonna go back to the very beginning. I also have what do you call it? A PowerPoint ready, and then also so that you can be able to download it and read the instructions on your own. But I'm just going to search for mBlock here on Google, and then I'm going to go to Scratch 3.0 software. And this is mBlock for PC. mBlock for app is also possible. So if you have a tablet, you can also put it on a tablet. You don't have to have a PC or a laptop to use mBlock. But we're going to go with the PC version. There's two different mBlocks. They both work. I want to point that out. Both of these mBlocks work, but I'm going to use mBlock 3 because it's for Scratch 2.0. Then I'm going to go up here and hit download. I like to use version 3.411. There are other versions, like say you don't want to use that same version, you don't have to. They all should work. You can see there's Mac version, Chrome version, a Linux version. These are all different computer operating systems, but if you have a Windows, use this version right here, 3.411. You'll download it, and it will have we'll start downloading an executable. I already downloaded it before, so I'm just going to go into my downloads and pull it up. There it is. So you're going to click on that executable, and then it's going to show up with this pop-up box. Minimize this. Hit English, say OK for English, accept the user agreement, make sure you get your parents' permission if you need your parents' permission to do this part. And then you're going to create a desktop shortcut. And again, next. And then you're going to install. Since I've already installed, I'm not going to click install. But once it's installed, it's going to go through, some tasks. And then it's going to say I installed, and you can say finish from there. So now that it's installed, you can go to can you still see my screen? Yeah. Okay. You're going to go to your desktop, and it's going to be right here, and you can click on it, double click on it, and then you're going to be able to pull up mBlock. From there, you want to do one special thing. This is you only have to do this once. You don't have to do this every time you open mBlock. You just have to do it the very first time you open up mBlock. And you're going to do extensions. Go to Manage Extensions, like this. And then you're going to search Eutronics. See, I've already have searched it, but I'm going to type it again. Eutronics, which is the name of your robot. So on your kit, there's the name of your kit is called the Eutronics Robot Kit. You want to put in Eutronics, and this is going to pop up. Now, this is important. You have to be connected to the internet to do this. If you're not connected to the internet, it won't be able to show up. So I've already installed it, obviously, but if you hadn't, there would be an install button right here. And you would want to click Install. And then it would install this library. A library is another term that, or an extension. They're both mean the same thing, and basically it adds the functionality for mBlock to talk to a Eutronics robot. So say you were to get another Eutronics robot sometime in the future, you would be able to use the same library or extension. So once you've added, once you say install, or add extension, you can X out of it and it's installed, and this is going to pop up. Now we're going to start using this in a little bit, and so this menu up here at the very top is going to be super important. There's all these categories, right? Your robot program is going to be right here, and you can drag them over here. Once you install that extension, this box pops up, Eutronics Program. Okay. So the next thing, so there's an Arduino process too. It's super similar. You would go back to, you'd go back here, you'd search Arduino, and then you would pull up the Arduino IDE. You would download it, use the Windows installer. It would download an executable just like mBlock. You would click on it and you go through the install process. I laid that out in the PowerPoint. But I want to focus on mBlock for today's session, just so that you can kind of get more familiar with how to program in it and how this program works and how to play with it. So there's two parts to playing with mBlock. You can play with it without the robot. You don't have to actually use the robot. Say you just want to play with it and think about coding in general. Like I said, we're going to be using this menu right here a lot. All right. So I just want to set up a very simple program. I'm kind of gonna do it without talking, and then I just want you to watch, and then I'm gonna explain it in a second. So so let me just go ahead and put some blocks in here, and then I'll explain a little bit as I go, but then I'll explain it fully once I finish. So I just added this top level coding apparatus, and then I'm gonna go to a control right here.
So you don't need it.
Well, actually, let's see. Motion. Okay. I'm gonna say move 10 steps. And then I'm gonna say point in direction 90 degrees and then move 10 steps. So then I'm gonna click on here. And it moved 10 steps, but did not point in the direction. Oh, I didn't say turn. So so just kind of observe a little bit how I am just moving these around. And then I'm going to say this again. Let's see if this works. There we go. And then okay. And it turned 15 degrees. Okay, so let me just walk through what I just did. So, you can begin a program when it has this top level curve or something and it has an indent on the bottom. And you can see it's like a puzzle piece. So this puzzle piece can fit in here, and it kind of helps you with highlights for you when you're moving in and out. You can also delete or change, like say you don't want this piece anymore, by moving them away from each other. So they snap to each other and they snap away from each other. You can also drag it back into the middle column and it will disappear. And so it's kind of descriptive, right? So when I click the flag, this flag right here, it moves 10 steps and it turns 15 degrees. So I'm just continuously clicking the flag right now, and that's how that's working. Okay. You can also change the variable. You can change it to whatever you want. You can say 30 degrees instead. And then I'm going to click it, and now it moves a little bit faster in a circle. Or I could say move 15 steps or 20 steps. Oh, let me take out this. I don't think that it's working as well with the 30 degrees. So I'm going to disappear that, and now I'm going to say move 20 steps. And now it's moving like that. Excuse me, sorry. Okay, so that's just the basic operation of how to use mBlock and what that looks like, how you can take it away, snap it to. And this particular example, always remember this: when flag is clicked, this is how you can play with it without a robot. You don't need a robot part for this one. There's a lot of other positions that you have. You can arbitrarily set things, and so if it moves, and then what it did was it moved 20 steps and then it set Y to 0. So you can see it's very descriptive. Or you can change that and say set Y to 10. So it's going to move 20 steps and then it's going to set Y back up to 10 because 20 minus 10 is 10. So those are the different types of things you can do. This is how you can change it. You can do any type of instructions that you see here. This is a drop down, a random horizontal point. So, and then it picked a random horizontal point. So basic programming, you're totally talking to the computer at this point, and the Panda kind of helps you visualize what you're doing. But now, if we want to actually program for our Arduino on our robot that we've been working on so hard, we're going to go into this robot section. We're going to say Utronics program. And there are a couple of things in here that might be confusing because it's not on our robot. So remember, Utronics is a whole fleet of robots. There are a bunch of robots that have this. So there are also robots with more features or gadgets on them. So for example, serial write text hello. We don't have an LCD screen on our robot, so that wouldn't work on our robot. Serial available bytes, that would do an output, but we don't really understand that just yet. What we can do though, and we know we can do this, is set Utronics robot card to go forward with a speed of 150. So this is just moving the robot car forward. We can also set the Utronics servo module angle. So that's your where your eyes of your robot, you know, where it swivels and goes around. That's your servo, and you can set the servo module angle. Okay, so those are two basic things that we can do. You can do a lot with this. So you can do things like move it forward. Oops, sorry, I'm gonna hit back. You can move it forward. Move it forward, backward, left, right, and you can also tell it to stop. You can set the speed in which it moves, 100, 125, 150, 175, you know, all those things. You can also change the angle, You can also change the servo module angle. So I'm gonna do a couple things. I'm just gonna make it different because why not? I'm gonna say 200, and then I'll say 45. It's not working for me. Okay, I'm gonna type it. You can also type it, you don't have to click. So I'm gonna say 45, and I just typed that with my keyboard. Now it was doing something, so if you double click anywhere where it's not white, if you double click on the, oops, let me see. It's fighting me. There we go. If you double click on the blue part, it will pop up with this, right? And this is your Arduino code. I totally suggest you study this if you have the interest and the time. is the actual Arduino code that's going to be going to your robot, and you can scroll down and you can look for your variables, right? And so in here you see it says left motor 1 set speed to 200, which is what we did right here. All right, left motor 1 set speed to 200. And you can go through and just understand how your variables change your code, because I can also come back here and say go to 125 and then look at my code again, and here it's changed to 125. And then here's the servo. It says 45, which is what we set it to right here, 45. So this shows you what it's going to be saying to the Arduino. So before we can send it to the Arduino, we need to connect it to our board. I already have my Arduino connected to my computer. So it took a second to connect. And then I can go to connect. And this will also be in your PowerPoint, what I'll send to you. Serial port COM3. So it's really important that when you connect your Arduino, you go to this section, because if you don't, it won't connect. So connect your robot, look at the menu connect, go to serial port, click COM3, and now it says serial port connected right here. Once you've connected it, you can do this part, upgrade firmware. I suggest that you do this once if you've been working on it for like a couple of months and you haven't done it in a while. Upgrade firmware again. Again, this will be in the PowerPoint. So upgrade firmware, and it will take you through some steps and you can upgrade your firmware. This makes sure that your Utronics hardware and your Utronics code is the most up to date, because the people who put this robot together, they're always tweaking the program, making sure that's the best. And sometimes there's an upgrade where you can update the basic hardware on your robot. So this is a really good chance and opportunity, and it helps, promote a healthy robot. All right, so after you've done that, you have fully connected your robot to your computer and to mBlock. And then you can say upload to Arduino, and you just hit that and it will upload to Arduino the code that you have provided it, and then it will start running right away. So you can put your robot on the ground and it will start using your code. One more thing I wanted to point out is that you can stack as many of these together as you want, right? So it's important when you're doing robots is to think about the design of your robot and the design of the functionality of your robot. Because you're changing this manually, it will no longer be in the automatic obstacle mode detection. It won't automatically detect an obstacle and turn the servo head because you're manually doing that. So I think the best case scenario for you using this robot code on your own is to build an obstacle course. So when you're trying to work on your robot, build an obstacle course in your house, maybe with old boxes, shoe boxes, and then try to predict what direction the robot needs to turn, what it needs to see, and then code that out. So for example, if I had a hallway in my house that I wanted my robot to go down, then I would say, okay, I want you to move forward with a speed of 200. And then you set that speed, and then you can say, now turn your servo 45, or you can say stay straight. So 90 degrees would be straight in this case. So that's how I would suggest you work with this code, is to build an obstacle course in your house or at your school or wherever you are, and then try to send your robot down and see what happens. See if it can stay straight. If it can't stay straight, maybe check your wheels, make sure that your wheels are on tight, and then see where you can go from there. You can also say, So after you go on with the speed, you turn your module, you can say turn right. You know, with the speed, maybe you want to bring it down a little bit and say, okay, turn right with the speed of 100. Okay, and then does your servo need to move? Maybe, maybe not. You can make that decision if your servo needs to see something. But generally, you're going to be its eyes and ears at this point, because you're going to be trying to predict which way it needs to go. Say it was to go into a room, then it would want to turn right. Maybe you want it to turn right a little slower, so that's why you would change the speed. Okay, so here's one more thing I want to, another thing I want to mention. Say you were like using these other pieces of the puzzle, you know, and you went to a control and you were trying to use other things. It actually won't work. So if I try to say upload to Arduino with this stuff in it, oh wait, it looks like it did work. Whoops. All right, let me not do that. Okay, let me actually try to find something that actually doesn't work. I want to show you what it looks like when it doesn't work, so you know what's happening. Oh, oh, okay. Let's see. Let's see. I'm gonna try to break it basically, which is really important. Robots break all the time, and I think we saw that when we were all together. Excuse me. So let me try to see if I can break it really quickly. I'm just gonna put in these random things and see what happens. Nope, it's still working. Let's see. I actually didn't test breaking it before now, which is bad on my part. Okay. Data and blocks. There we go. All right, now I have everything back. I just hit back on the very top right where it said upload to Arduino, and so this said upload to Arduino, and then I hit back right here. So I'm gonna try to break it again. That's what I'm trying to do. Just try to break it with something that it doesn't like. Where? Let me see. I know there's a couple of things that it doesn't really like. Well, okay, let's try something like this. Set instrument 2. And then something else random. Reset timer. Okay, so now I'm gonna go back to where it says, okay, so here it goes. It says unsupported blocks found, remove them to continue. Change volume by -10 is not supported. Set instrument to 1 is also not supported. So that literally means what it means. You want to remove these in order to be able to send your code to your robot. So these unsupported blocks are found, and I'm going to say okay. Now, if I don't remember, it's okay. Like I'll put that away, deleted it by dragging it to the middle column. I'll put reset timer there. Say I forgot like all the ones that I was supposed to do. So when I double click to try to go to Arduino, it's gonna say, oh, you still forgot some. Change volume by -10, it's not supported. Remove it to continue. I'm gonna say okay. So if at any time you see that, I'm also gonna delete this one because it's supported. So if at any time you see that type of pop-up, it's not going to let you be able to go to your Arduino code before you change out the things that it does not support. So I'm double clicking right now on the blue part of the code. So I'm double clicking on this section right here. And then from there, I can say upload to Arduino. Now here's another really important key. Anytime you upload to Arduino, anytime you hit this blue button, you are wiping the old code. Like the old code no longer exists on that Arduino. So everything from the automatic code that it went on when you first turned the robot on, that's also gone. So you'd have to re-upload old code. So here's something that's really important to programmers and developers. You're going to want to save your project regularly. So all I have to do is go over there to File. I'm going to do that one more time. I go to File and Save Project just like you would any other program. And then I can save the program anywhere I want on my computer. I'm going to save it on my desktop for now. I'm going to say First Program. And now I have a saved program. It shows you right here that it's saved. All right, but it also shows that it's disconnected. So again, to connect your robot, I just want to show you one more time, just in case. You go to serial port, say COM3. Your Arduino will probably start lighting up, and it will start blinking, saying I'm connected. And it shows up that it shows its IP address right here when it's connected. So you can also check if you see a blue check mark right here on serial port and then whatever COM, it's connected. COM3, just to point out, COM3 is the USB port that you're connected to. That's what that means, COM3. So if you are on another USB port, it could say something like COM5 or COM1 or something like that. So that's what that means. It's just letting you know what port it is in your USB. Okay, so now you can see it's a serial port connected at the very top. We're way at the top of the mBlock program. It says serial port connected and also says saved. And at any given time, if you change your program, so I'm going to add something to it. I'm going to add set electronics port for it. I'm just adding another block. It says serial port connected, but it also says not saved. So make sure you go over here regularly and say save, and then it will save your project. You won't have to save it under a new name. It will just save the project. So this is something for you to play around with. You can also add things to your Arduino. If you need help with that later, I can definitely help you add new things. You don't have a Bluetooth connection, which is really fun, and I can walk you through a tutorial on how to add a Bluetooth connection to your Arduino. That would mean it actually means doing some soldering, and then yeah, my basic suggestion is to set up some type of obstacle course in your house for the robot to kind of maneuver through. Let me see real quick if there's one more operator that I can add that's helpful. Let's just real quick try this. I'm gonna say repeat 10 times, and I'm gonna add it here, and then you see it will go to the robot. It will repeat this 10 times, and then this is gonna be helpful for you when you're trying to navigate. Say you wanted to turn right, turn left, you wanted to go backwards, then you can say, you can put another repeat down here and maybe add new blocks, or depending on how you feel or what want to do, you can say backward. So now it's gonna repeat this scenario 10 times. 10 times it's gonna go forward with the speed of 200, and I'm guessing that it's already on an interval. So it's gonna go forward with the speed of 200 for however many times 10, and then, or not 10, but however many times it wants to do it in one instance. And then it's gonna set the electronics servo angle to 90. I guess for that to make sense, we should change it. Let's change the servo module angle down here, and we'll change it to 45. So now think about where your robot is. Now it's moving forward with the speed of 200. Its servo angle is at 90, and then you're going to tell it to go right with the speed of 100, which is a slower speed, and then it's going to change its servo angle to 45. And then it's going to go way back to the beginning and do this 10 times. It's going to go forward with the speed of 200. Then it's going to set its servo angle from 45 to 90, and then it's going to go right. So you can kind of see in your head that the robot is going to go along this path. It's a predetermined path that you control. And then after it finishes for 10 times, it's going to do something else 10 times. And it's going to back up backwards at a speed of 150 for 10 instances. And then the program is going to end. So that's the program that I wrote right here. And you can write your own program, and it's going to follow the path that you set for it. And like I said, I think a really good use of this is to use a obstacle course. Okay, so I think that's pretty much what I have. I want to fill in with your questions. This is what the thing to remember about engineering teachers or robotics teachers in general is we're showing it to you the way I learned it. So this is how I learned it and how I understand it, but that doesn't mean it's how you understand it or that I've actually answered even like a little bit of your questions. So let's just go ahead and start talking about it. Tell me where you're confused, what your questions are. Spurge, do you want to help on this part?
Yeah, no problem. Let me, don't see any questions in the chat room, but let me look and see if take people off of mute.
Yeah. What kind of questions do you have?
So, Lilian, did you have any questions?
No.
Do you feel like you could get started and play with this?
I don't have my bot right now, but I will try it when I get my robot.
Okay. Well, that's fine. Yeah, as long as it looks like there's a place where you can get started from is my main focus.
Awesome. And I think I saw Noah and
Thank you.
Yeah, no worries.
Let me see.
Well, let me go ahead, if you're still thinking of questions, let me go ahead and show you how to revert your robot back. So this is the Arduino IDE. And if you want to revert your robot back from the code that you put in to the original programming where it was avoiding obstacles, you would want to go to Arduino. So anytime you want to go to Arduino, you can just search for it in your computer and it would pull up the program, Arduino. And from there, you would want to do a couple of things. Oh, well, actually, there's one more step. Let me show you. Utronics has a whole package that you can download from GitHub. Utronics GitHub. And they're the smart robot car. And this is going to be in your PowerPoint too. So I just said Utronics GitHub. You could also say, well, yeah. And then it says right here, Utronics smart robot car. I click on this. And then I'm going to download right here on this green button. And I'm going to download the zip. It's going to download it into my folder. Of course, I already have it. It's right here. This is my smart robot car Arduino master folder. I'm going to unzip it like this, where I say extract. Sorry. And it will unzip into a folder. I already have the folder open, so I'm just going to add a 1 there so it shows up as a different folder. So now I have this folder on my computer. You're going to go back to Arduino and you're going to install a new library. So again, this is like just like what we did on mBlock, but it's for Arduino. And this will all be in the PowerPoint. So you're going to include and add a zip library. And you're going to navigate to your folder. So here's the 2 folders I already had, right? This is the one I just downloaded. You're going to navigate and just keep clicking until you find the whole library of things. Excuse me. Sorry. And then you're going to click on this. Just click on it once, and you're going to say open. And from there, it's going to actually install the library for you. And then after you do that, I'm going to cancel because I already have it installed. You're going to be able to go to examples. And down here at the very, very bottom will be a library for Utronic Smart Robot Car. And then you can go over to examples and you can click on your model number. So your model number from the robots that we did the other day are 69. So K0069. All right. And these are other models that you can get and purchase if you wanted to. But this is the one that we use. You have a pop-up that comes up right here. Again, you're going to do the same thing to make sure that your robot is connected to Arduino. So the board is right here. It has a port. Make sure you connect it to that port. And let's just check it to make sure it did. So yep, it says port COM3, which is the same one that we saw in mBlock. And it has a check mark next to it. So now your Arduino is connected to this Arduino program. It's connected to your Arduino board. And from there, you can say upload, and it will upload the original code back to your Arduino. And then from there, you can just put it on the ground, and it should do the same obstacle thing. Yeah, so any questions on that or anything else? The other thing I wanted to mention was troubleshooting your robot. Sometimes you'll turn your robot on and it won't turn on and it won't work. So there are a couple things that you should do first, like when that happens to you. Jiggle your battery around. Take your batteries out and put them back in. Sometimes, because this is a cheaper board and setup, the battery pack just kind of gets a little funky. And you just need to jiggle it a little bit and it will start. In fact, Noah, I think that's one of the problems we had when we first tried to turn on your robot, is it wouldn't start. And then the other things to notice is like maybe your cords are not connected properly. Make sure they're always seated into your board correctly. Like they just fit and they're just pressed down and they're really tight. Say your wheels aren't working, like one wheel refuses to turn. Flip your robot over on its backside. Make sure that the wires are still connected. I actually have a problem with my robot right now where one of the wires disconnected from the motor. So it wasn't connected, right? So make sure that all your wires, even your servo wire, is always connected and that they're not broken. It's really easy to repair, so don't get discouraged if there is a wire that's broken. What you would have to do to repair it is probably a little bit of soldering. And if you ever run across that problem and you don't know how to fix it, don't hesitate to reach out to me and I can help you figure out resources and how to get it fixed. Maybe there's even a way where you can send it to me and I can help you fix it since I'm not in town. But there's also plenty of roboticists and people who know how to use a soldering iron in San Diego. Let's see, any other? Sometimes your Arduino board is not, it has all these pins in it, right? Make sure those pins are always seated correctly and that you're not seeing things kind of like pull away from the board itself. That would be bad. Sometimes you can just push those back in. Make sure things aren't bending at any angles. If you were to unplug one of those, one of your sets of pins, unplug it and put it back in, always make sure that you put it back in the correct way. And we talked about this the day of, but anything that's black or brown on your device, that should always be on the ground side or on the negative sign. There's a negative sign, or there's a word that says GND, which means ground. So you want to make sure that your black cord or your brown cord is closest to that symbol for ground, which is negative or GND. The same for your red cords. You always want to make sure they're the nearest to VCC, which stands for voltage. And that's where the power is coming. So your battery is providing power to the board. And the board the board signifies power by a plus sign or VCC. And that's where your red cord should always be pointed towards. Sometimes ground is accompanied not by a brown or black cord, but by dashes or dots. So make sure that if you have dot, 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 it's by the ground. For in the same way, voltage will be accompanied by dashes, like dash, dash, dash. And that's, you can see that on your eyes, on your sensor, your sonar, shows that type of thing. It has dot, dot, dot on one side and dash, dash, dash on the far right on the other side. And it goes into the board and it says GND on one side and VCC on the other side. So make sure they line up. Let's see. Other reasons why your program might not be working or getting to your robot is, again, because it's not connected to your computer. So make sure you always have that COM labeled. Let's see. Or maybe you didn't program it to say something. Maybe it's saying, oh, I did everything you told me to do, but it didn't result in a movement or a servo change. So go back and look at your code and make sure you actually program it to move forward or to do something and not to stand still. So for example, if you had just put in, I'm going to erase some of my mBlock code. I'm just going to show you real quick what it might look like if your code wasn't doing anything to your robot. I'm going to say like this. If you had programmed it to say stop, because that's one of the options here. If you say stop and that's all you send to your robot, it will sit there and it won't do anything. And it will repeat that 10 times and it will work, but you won't see any movement because you didn't program movement in it. So sometimes that's another reason why your robot might not be responding or moving in any way. Also, I just want to remind you, you don't have to have a robot to work with mBlock. You can go ahead and say something like, hey, I just want to think about like what my talking to a computer means. So you can say when clicked and then add repeat 10 or something like that. Oops, come on, work with me. Repeat 10. I'm going to, go forward 10 times or something like that. You can create more and more complicated things the more you look at it and think about it. The way I like to program robots is I do like to sit and think about what I'm doing. Like I have this objective, say I want to go through an obstacle course. I like to just look at it and without even programming, just think about what I'm going to ask the robot to do. I'm going to ask it to turn right, turn left, and things like that. And so that's good to think about and to just kind of do it before you even get to programming. It kind of helps me at least. So does this work? Sometimes if it doesn't work again, like it's like I did what you asked, but it's not what you asked did not actually make me move. So you can think about it by like saying, okay, if that doesn't work, why don't I try something else? So here I'm going to try something else. I'm going to move this. I'm going to say move 10 steps instead. And it's going to move 10 steps upside down, but it's going to move 10 steps. So you just keep trying until you get something to move. And when you figure out something has worked, then you say, okay, what can I do that's similar to that? And then what can I do that is actually what I wanted to do? Like, okay, I really do need it to turn 15 degrees and move another 10 steps. So we just keep trying until it works. And if you want to do a one-on-one session where we're just coding and just working on our coding skills, I'm totally up for that. Just reach out to me and we can work specifically on our coding skills. The thing about being a roboticist, a young roboticist, is that you're learning a bunch of different skills at once. You're learning how to build a robot. You're learning how to troubleshoot your robot and make sure that it doesn't break. You're also learning how to connect your robot to the computer, and you're learning how to program your robot. In like the real world workplace, there are people whose only job is one of those things. Like their only job is to build the robot. Their only job is to connect the robot. And in some other places, sometimes they have to be just like you, where they have to do all the things at once. But those in themselves are separate jobs. So you're becoming a very versatile roboticist by having to do all these things yourself. And it really is going to help you in the future when you want to play with other bigger robots. You'll be able to like learn from what you've done today and keep doing and apply that to other robots in the future. So this is just like a stepping stone to bigger and more complicated robots and more complicated code. And I promise you, if you keep working on it in some semblance or fashion, it will help. I just really quickly want to show you one more thing too. You can look up tutorials on how to program with mBlock. So mBlock coding tutorials, you can just Google that, and there are a bunch of lessons. So some of these coding tutorials obviously do not pertain to your robot, but by still listening to them and watching them, you're going to learn and get ideas for things you can do with your robot. That's how I learned to program. I saw someone do something really interesting. I was like, oh, how do I do that? And then I would research how they did it and see if I could apply it to my program. That's going to really help you when you go to school for this type of thing, because they'll ask you those questions all the time. They'll say, this is what we did, but we want you to apply it in this specific way. So now you have to go figure out how to do that. So that's kind of what, it's a taste of what engineering school might look like for you in the future. For sure. Any questions from there?
Hi, Camille. I think there's a question. When the robot starts rolling and then it looks to the left and it looks to the right, what is that code in the mBlock?
Yeah, sure. So there are two kind of types, two ways I can answer that question. So first off, you can definitely, I'm gonna go ahead and put it, I'm gonna do that code, specifically that code here. But I think you'll notice something as I'm doing it. So I'm gonna say Utronics program. This is the servo. The servo is the head, and that's where the eyes are, and that's what controls the movement. So this is the servo module. That's what it's called. Excuse me. 90 degrees is pointed ahead, straight ahead. So when it looks to the right, it's gonna move at an angle about 15 degrees, or maybe even an angle of 30 degrees. So 90 is your starting point. So if you want it to look to the right 30 degrees, you're gonna wanna add or subtract 30 degrees from it. And I actually haven't tested that to see which direction it is, but let's just assume that to look to the right is gonna be plus 30 degrees. I'm gonna type 90 plus 30, which is 120, okay? Then I'm gonna add a second one, and I'm gonna say 90 minus 30, which is 60. I'm gonna type that. So now we have made it so that the servo both looks to the right and looks to the left. However, sometimes the servo will then revert right back to straight. So another thing you might want to do is just say, okay, now look straight again. So it looked to the right, it looked to the left, and now it's back to straight. Now here's the thing about this code. It's obviously not doing that automatically, you're coding it. So the thing to think about the difference between the mBlock code and the Arduino code is this code allows the robot to operate a little bit more autonomously. So it's actually working where it's like, okay, I'm up and now I'm looking to the right and to the left. But the reason why it looks to the right and to the left when it starts up is because it's like, oh, I need to look at my surroundings. It's not saying, oh, I need to turn my servo angle 120 and 60. It's saying, I need to check my surroundings. And then it responds to a code that says, well, to check your surroundings, look to the right, 120, look to the left, 60. And then proceed on your way if there are no obstructions in your way. That's the difference between the mBlock coding and the Arduino coding is the Arduino makes the robot, the Arduino code on the Arduino, on this section, lets the robot work autonomously. In mBlock, you're hard coding. That's a new term. Hard coding is where you're specifically telling it what to do. I'm telling you to look to the right 120. I'm telling you to look to the right 60. So that's the difference between the mBlock code and the Arduino code.
Question. So if you were to reset that robot back to factory settings, and could you reverse engineer their code in the mBlock? Like, could you load the Arduino code up from the original?
Yeah, sure. So here's remember when you double click and you can see the Arduino code that it's uploading? This is the Arduino code that you have produced. So you could go to Arduino over here and look at everything they've done. And at any given time, and I'm not gonna post this because I have no idea what this particular block of code does. At any given time, you can click copy and move it over here, you know, and say, should be able to. Oh, edit. Okay, here you go. So it's going to edit with Arduino IDE. I haven't done this, sorry. So it's going to edit with Arduino IDE. You're going to allow access. And now this code is in Arduino IDE. And so from here, you could go ahead and paste that code and try to do reverse engineering. Let me give you a walkthrough of what we're looking at here. So you can kind of get started. This is going to take oh, go ahead. Did someone say something? Okay. This is going to take a lot of reading. If you want to actually do this and reverse engineer the code, you're going to have to read up on what these different things mean. You're going to need to go maybe to, you could go to Google and say Arduino Code 101, or Basics would be another one. And you're going to need to start reading about Arduino coding and how to do it. Arduino coding basics is probably a better way to search for that. And it has videos here. You can go to Arduino tutorials, which is on the Arduino website. If you don't understand how any one person explains to you Arduino code on the internet, pick a different tutorial. That's how I go about things. If I don't understand one person, then I'll go to another one. I'm not sure why the Arduino website didn't pop up there. But you can get Arduino code examples, built-in examples on the Arduino system. Like right here, they're built-in examples. So you can learn all this. I'm going to point out for you a couple of things, and hopefully that will help you get started and kind of see that it's not too intimidating. So everything that is not after a hashtag is going to be code. Anything that is immediately after a hashtag is a comment. Or no, sorry, not a comment. Hashtag include. Oh, okay, no, we're sorry. Different coding. I have to make sure I'm not in one code. The actual comments. Let me erase what I just said. Comments are actually double forward spaces right here. These are comments. Hashtag include is totally code. Hashtag include is talking about a header file. So what it's doing is there's a header file, just like any other program you're using. Say you're in Microsoft Word and you type up a document and you click save, right? And it saves it as a doc file. .h files are the same in that they're a file, but instead of being a doc file, it's a .h file. Hashtag include is telling the code to append or to include all the code from this .h file to this script. Okay, and so this is a really special file because it's what controls your motors, and this one controls your servo, right? So there's a whole other set of code that controls the servo and the UC motor. And when I get started on code like this, I like to think of it as, oh, I don't need to think about that right now. Eventually you might want to change the code, but for now you can be like, oh, I don't need to think about that right now. What you want to think about is everything here. But make sure you never delete these things. That's why I wanted to mention it. Hashtag include is adding code that you don't need to think about, but is very important to the operation of your robot. So make sure you never delete those. All right, so real quickly, and this again, I would totally encourage you to start reading about Arduino code, and it will definitely lay these out. But there are types and there are classes, and those are control how a robot works. There are names too. One of the things that I thought was really cool about coding is that you can name a code whatever you want. Not everything is like, oh, this is such and this does such and such. Sometimes you can create the parts of the code that you want to use. And so you can name them whenever you want. And this is an example of the naming a class, which does these things. So there's syntax. Syntax is another word that you might want to think about when you're thinking about coding. This symbol right here is part of the syntax. So after you named your code, classified your code, then you're going to have commands, and those generally go between these brackets. And every time there's a new line in the code, the code is delineated by the semicolon to say stop. This is the end of whatever this particular command is. And that changes. But you can see it kind of play out through the rest of the code. Like everything kind of has a name, it has a class, and it has a stop, which is the semicolon. It has equal signs. There's all kinds of things in here that you can look at. And again, it's going to be much easier to understand if you go through Arduino coding basics and watch an actual video to like think about how this code is talking to the computer and what it's saying. But yes, to answer the first question or the last question, you can reverse engineer it through mBlock. You have to go ahead and you can click on this right here and say edit with Arduino IDE, and then start adding things over. Or you could even make sure you save a copy of this, but you could start from right here if you wanted to, and make little tweaks to the Arduino code from here and upload this code to your robot. You can make little tweaks once you understand. You don't have to understand a lot. You just make little tweaks and see what happens. You can see what will break your robot. Break the code of the robot. And again, when I say break the robot, literally almost every time I say that, it is never like a full destruction. I've completely broken the robot. It no longer works. That's like never the case. When I say break a robot, I really mean experiment. And I think that's a really cool thing about robotics is breaking a robot is never really like, oh, I've destroyed the robot. Breaking a robot means I've experimented with the robot. And it's not working, but I can get it to work again. So that's really why it's really important to save your work and also save backups of your work, because you can always revert it back to how it was working before. Any more questions? Did I answer that one fully, Spurge?
I believe you answered the question perfectly. Does anybody else in the session have any questions?
No.
Just want to say, Camille, thank you so much for all that you've done for this program. I've heard nothing but great feedback from the first part, and I'm sure to hear a lot of great feedback for part 2. Some of the young people were busy with family stuff this weekend, but they definitely requested a download of the video. So I guess we'll post this on your YouTube channel or whichever channel. However, we'll post it somewhere online and forward the link to everybody who wants to view it in the future.
Yeah, that sounds great. If anything looks confusing or you want more explanation, reach out. And there are plenty. I always like to say there's a million mentors in the world. So there are a million people that are possible that can answer the question besides me. You can definitely feel free to reach out to someone else, but I am definitely willing to work with you. And make sure you just get your questions answered. Don't sit there with an unanswered question. It's going to be a lot better and a lot more fun if you get your questions answered quickly, so you can be up and running your ideas and your experiments that much more quickly. So get your questions answered. Try to go on and look for tutorials, whether they're videos or you can read about Arduino coding and mBlock coding and about the robots themselves. I'm also going to have a PowerPoint so you can go along without my voice if you want to do it that way. And yeah, ask me questions. Schedule a one-on-one session with me or maybe with Spurge, and learn more about robots.
Camille, is there any place online that anybody wants to follow you in the future? Do you have any social media accounts that you encourage others to follow? And do you have an email address for people to contact you in the future?
Yeah, let me pull up my notepad real quick so I can type it here. And then, of course, it will be in an email. But you can, if you're on Twitter, you can find me at NIKYMILL. NIKKYMILL. And I post on there about like my adventures, so like if I'm going to go speak somewhere, and also about robot things, and about being a woman of color in technology. You can also, and I suggest this for everybody, it doesn't matter what grade you're in, but if your parents allow you, feel free to find me on LinkedIn as well. So you can find me on linkedin.com, and this is how you can get to my LinkedIn page. And I would love to connect with you on LinkedIn. And that's a really great way to start showcasing what you know and what you've been learning in the past couple of days, for other people to see it. Because after you've learned something, you can teach someone else, or you can be a part of an important team. So LinkedIn is one of the ways that I like to share my goals and also the things that I've been learning, whether it's in school or on a job or even teaching. I've learned a lot by teaching everyone here today, so I'll even showcase that. And then how you can email me, I'm going to say email. You can email me here. It's a Gmail account. And email me at any time. I would say use the subject line so that it really comes across. Say something like robotics program, or you can say robotics question. And then I'll be sure to see that and get a reply to you as soon as I can. Yeah. So feel free to reach out anytime.
Thank you so much again, Camille. If nobody has anything else, I want to thank the parents who may still be on the call listening and the young people who joined the program. Without you, this wouldn't have been possible. So I appreciate your participation, and feel free to reach out to me, Spurge, at lilSTAR.org, SPURGE at lilstar.org. If you want to learn more information about joining our robotics team here in Southeastern Division of San Diego, and for any other inquiries regarding the program, I'm open to share whatever information Camille suggests. And thanks again for your participation. So.
Thank you, Spurgeon. Thank you, Miss Eddy, for your time. Appreciate it.
Thank you. Yeah, no problem. Thank you.
Thank you. Happy holidays to you and your family.
Yes, thank you.
Thank you.
Thank you. Thank you for coming, Noah.
Thank you.